Welcome to the second video in Unit 2. This is the derivative and tangent line problem, Part 2. And these are the objectives. This is what we're going to do. We're going to continue working with the slope of the tangent line, the derivative. So this is the summary that we had at the end of the last video. So you already have the first 4 sentences already written down as part of that last video. So remember that the derivative finds the slope of a curve at any point. The instantaneous rate of change at a point is also the derivative. If f is differentiable at x equals c, then f is continuous at x equals c. However, if f is continuous at x equals c, then it may or may not be differentiable. And this is the new one. A function is not differentiable at the points where the limit does not exist. Okay, so using those definitions, let's look at a graph and determine whether the derivative would exist there. All right, so it has to be continuous and the limit has to exist. All right, so let's look then at the first one, the derivative as -8. Now it doesn't ask you to find the derivative, it just says does it exist. All right, so I go to -8 and I see that the limit exists and it's continuous, so yes. -6, the limit exists and it's continuous, so yes. -4, the limit exists but it's not continuous, so no derivative. At 2, no limit, no derivative. At 3, there's a limit and the derivative exists. At 4, no limit, no derivative. So where would a derivative fail to exist on a graph? Two things. Where there's a discontinuity. It is not continuous and the limit does not exist. Not and or, right? Because here, at this one, the limit exists, but the point doesn't. It's not continuous. So it has to be both. So let's look at some lines and try to think what the derivative of that line would be. Okay, because remember that the derivative is the slope of the line tangent. Well, the line tangent to a line, right, is going to be the slope of that line. So for instance, right here, this is the line y equals 1. Well, what's the slope of that line? It's a horizontal line. The slope is 0. So the slope of the line of the graph is the derivative graph. So the derivative graph is equal to 0. On this one, just the regular graph is y equals t. Well, what's the slope of this line? Well, the slope is understood to be 1, right? So if the slope of this line is 1, then the derivative graph is going to be the graph equal to 1. So let's look at parabola graphs. Okay, we'll look at parabola graphs. So on this one, the one over here on the left, we see that we have a parabola that is concave up, passes through the origin, right? And so what we're looking at is that on this side, the tangent lines would have a decidedly negative slope until it got to here. Okay, and then the tangent lines for this curve would have a positive slope. All right, so what would the derivative graph look like? The derivative graph would show that everywhere the tangent lines were negative, it will be below the x-axis, negative. And then when it's not either, when it changes from from decreasing to increasing, right, when it changes, then now the slope of the tangent line is positive. So the rest of the graph is above the x-axis. Okay, so let's see if that bears out here. We have the blue parabola, right? We have a blue parabola. Notice that it decreases till it stops at a minimum and then begins to increase after that, right? So as it decreases and goes to increasing, the slopes of the tangent lines on the decreasing are going to be negative, and the slopes of the increasing are going to be positive. So let's see what we have. Let's follow this. So from here, okay, from infinity to -2, it's going to be below the x-axis. Where it's on the axis is the minimum. And then past that, as it's increasing, is going to be above the x-axis. All right, so do you see here that this is the minimum? And the minimum on the derivative graph is going to be 0, changing from negative to positive. Another interesting fact when you're finding the graph of the derivative is that the derivative graph will be 1 less degree than the original function. Okay, so we can see here this is a cubic graph, right? And this is a parabola. So which one of these is going to be the derivative graph? It will be the one that is 1 less, so 1 less degree. So the cubic, right, x to the third, that's going to be the polynomial function, whereas the x squared function will be its derivative. And I'm using that notation. I could have also said this, which probably means the same. Okay, so let's analyze it for just a second. All right, we see that this is increasing over the entire domain. We call that monotonic, increasing over the entire domain. It does not have a minimum or a maximum because it's increasing. It never changes from increasing to decreasing. And so since this is always increasing, notice that the derivative graph is all above the x-axis. And it doesn't touch anywhere because there's no min or max. Okay, let's see if we can draw the graph of the derivative function by analyzing the function itself and analyzing where the slopes would be of the tangent lines as we move along this curve. All right, so first of all, let's notice that this is increasing to a maximum, and then it is decreasing to a minimum, and then is increasing again exponentially. All right, so remember, as a function increases, the slopes of the tangent line will be positive. At a maximum, the slope will be 0, or on the x-axis, and then as it decreases, the slope of the tangent lines will be negative, and then as it increases, the slopes of the tangent line will be positive. All right, so everywhere that it is positive, my derivative graph is going to be below the x-axis. Okay, for every max or min, it's going to be on the x-axis. And if it is decreasing, it'll be below the x-axis. All right, and further, I know that the derivative graph is going to be 1 less degree. So this, for instance, has 2 turns. So this is an x to the third function. This is a cubic function. So my derivative graph is going to be an x squared function. It's going to be a parabola, either that or that. All right, that'll be my derivative function. So I'm going to start over here, and I know that this is increasing, so it's going to be above. I also know that here at this maximum, it will be on the x-axis, right? And then as it's decreasing, it will be below, and then here it will be on, and then after this it will be increasing again. So we draw it in. It's going to be above the x-axis until it gets to here. From here to here it is below, and from here on it's up. And that's my derivative graph. So here's another way of saying what I said. We said if the derivative is positive. If the derivative is positive, then the function is increasing. If the derivative is negative, then the function is decreasing. If it is 0, or on the x-axis, if the derivative graph is on the x-axis, then it is a max or min, usually. There can be another point there, which we'll talk about later. But this is important. Please write this down in your notes. Wow. Look at this graph. This is the function graph. Your challenge is to create the derivative graph. So, and I think you can, if you'll think about it. Some of you are thinking right now, I think I can do this. Draw it on your paper and see if you can come up with something that looks like a derivative graph for this. I want you to analyze increasing to a max, decreasing to a min, increasing to a max, decreasing to a min, increasing to a max, and decreasing. All right, think 1, 2, 3, 4, 5. So draw this on your paper and see if you can come up with the derivative graph. And I will see you, of course, in class.